In this example exercise, we're asked to write a program to swap the 4 bytes of an integer. An integer, of course, is a 32-bit entity, variable, and it has 4 bytes in it, each byte being 8 bits. It can be thought of as 4 bytes, but also thought of as a complete integer of 32 bits. We do this by using a feature of the C language called a union. A union, as defined, is a generic definition of an overlaid section of memory. That is, we can define a structure, as we have here, of 4 character variables, LL, LH, HL, HH, and tag that as in, and that is a structure with that tag. Also in the union, another section is defined as an unsigned integer called B. The union will take these two portions of definitions of variables and overlay them. Of course, an unsigned integer is a 32-bit chunk of memory, and this structure tagged in consists of 4 8-bit variables, and of course they are then overlaid with the B variable of any variable declared of type union out. So in main, the first thing we do is declare a variable of type union out called AA. We can assign using the integer format of the union a value, AA.B. We use the dot notation to specify which portion of the union we are addressing, and we set it equal to a 32-bit integer constant value, 1, 2, 3, 4, 5, 6, 7, 8. And we can print that out as AA.B is an integer, and we can print it out in hex %x. Now we define two 8-bit temporary variables of type character, the ALL variable and the LH variable. We can initialize the LL variable by accessing a portion of the union structure, union type, in the in structure part as AA.in. We need the .in tag in order to specify that we're accessing this portion of the union, and then .ll to say that we are accessing this 8-bit variable. And likewise, we assign the local variable LH as the LH part of the AA variable. We can assign AA.in.ll to be some 8-bit value, and we assign it to be the HH portion of the AA.in structure. That means we take this byte, store it in this byte. Likewise, we take the LL portion of the overlay structure and assign it to the HH variable, and then we can assign the HH variable to the LL, which is what we stored up here, and LH, the AA.in.LH is equal to AA.in.HL. So we take this value and put it in the LH part. And finally, the HL part is assigned the temporary variable LH, which we took out of the structure here. So these 8-bit values are 32 bits. They overlay the B integer part of the union, and accessing these 8-bit bytes means we're accessing pieces of this 32-bit integer. And if we print out, after doing these manipulations up here, AA.B again, we will see that the value of the integer has been changed to be swapped, such that it will read 78562312 from left to right instead of from right to left. So the integer value has been changed.